I'm not going to summarize my whole career. I'll have a small case study. I think links up quite nicely what we have heard during the day, that we should try to select some positive land use changes, some positive cases that can disrupt maybe our current systems. This is a proposal I have, that we can disrupt some of the existing highly developed systems that we have in Europe, and there is a big potential to make them much more efficient, or even though we thought they were efficient. The other way. Our agriculture is quite challenged in Europe because there's still a pressure for them to be more efficient in order to earn enough money. At the same time, there is an environmental pressure to make them less polluting, and this dual challenge is really difficult. After quite a lot of years of optimization, it's difficult to go any further. I also like to pinpoint the large import we have of protein feed to Europe. More than 30 million tons of soya products each year to Europe, more than 1 million tons alone to Denmark, even though we are a small country. We have 5 times as many pigs as people. So we do take in a lot of protein feed with a lot of phosphorus going in a line from South America to Denmark, where it's deposits in our soils. 50% of our phosphorus use comes from feed alone. Another challenge we have is the Water Framework Directive, which is really difficult for Danish farmers to fulfill. So I think it's time to look for radical innovation instead of more of the incremental ones that we have seen so far. And yeah, I had a point there, I forgot it. It's late in the day. But it's not so difficult to change. It's not so easy to change. Because I think this French study showed us nicely how our systems have been locked in over many years of development. Originally some historical choices of how the market has been divided between Europe and the US on grain products and soya products. Since then there's a technology lock-in happened, and finally it's all about economy and technology that makes it very difficult for farmers, even though they might see some solutions to change it. If we look at wheat production, we have reached a ceiling. Of course, there are still those few percents you can improve with a lot of efforts. So much research budget is put into raising wheat yields with a few percentages. This is possible in other countries of the world, but I think it's not really possible. It's not worthwhile to do it in Europe anymore. But there are really many drivers that ask us to do a change. And one of them is about the losses of nutrients. We've heard about it earlier today. There's a nice study from England, from Chalmers in Sweden, showing hotspots for that. That's the red areas, and that's the Northwestern Europe belt, where there's high precipitation, sandy soils, and a high pressure of animal production that makes these areas red. There are many other indicators in that study. Denmark is always a hotspot. It's nice. There's something to do. There's also hotspots in Southern Europe, not so dominating. And what they show in this study is that they introduce a new term of strategic perennialization, using more perennial crops in our agricultural system. In Denmark, we have 62% of total land cover in agriculture. Of these 62%, 80% is in annual crops. And those are the bad guys making all the problems with high nutrient leaching, high pesticide use, and depletion of soil carbon. So many of these problems, including the nutrient losses in this case, can be effectively avoided by strategic perennialization, as shown with the yellow color now in the right side. And one example of such a change could be to change a grain crop into a grassland. Still quite intensive land use, but with significant change in many of the parameters of emissions. It could also be tree crops. There are many possibilities, and it's neither God, the EU, or our Prime Minister that demands us how to use the land in the autumn. This is a September picture from our experiments at my institute, and you can choose yourself which kind of land cover you would have. There are so many options, but the logins in the system tells the farmer today what to do. We tried a lot of different combinations to see how productive, how environmental friendly systems were possible to develop. And from the many combinations, I've chosen a few interesting different cropping systems, showing that for these 3 years, as a mean, same land, same climate, it was possible to more or less double yield, going from what is quite typical on a Danish pig farm crop rotation with wheat and barley and rapeseed into a grassland. There's a double productivity, and for the grain crops we included, of course, both the grains and the straw yield, so it's total yield. It's not so magic, it's just we also mapped how much solar radiation was captured by the crops, and there's approximately a double capture in the grassland compared to the annual cropping system, so that's why, of course, they produce the double. Flipping the coin to look at then one of the environmental parameters, nitrate leaching, you see that maize was quite close in productivity to the grassland, but looking at nutrient leaching, it's awful. And we have much data on that. And this land has not seen manure for many years, so it's not because it's overloaded with nutrients, but the maize leaches a lot. The grassland was fertilized much higher than the maize, so it's not the fertilizer, it's the cropping system that is the problem. So it's not only nutrients, it's also about soil erosion. It's reduced greenhouse gas emission. If you change your land use, you will, under the grasses, store, and it's not only grasses, it's of course also legumes. It could be alfalfa, as we discussed earlier. For France, there's a lot of alfalfa used. There's a sharp reduction in pesticide use. Already in conventional systems, there's 40 to 50 times less use of pesticides in grasslands compared to the general cropping systems. And there's a small increase in biodiversity. You can work on that to make it bigger by diversifying your grassland. So the only problem is that what the hell should we do with all that grass? We can solve almost all of the problems of Danish agriculture, and I think most of Northwestern Europe, but there's of course no market for that grass as long as the farmers are producing what they need for their cows today. which are the only ones at the marketplace. So we looked into what are the properties this grass has, and here we have a broader picture of some of the cropping systems we compared. In the middle, the white bars you see are different types of grasses and grass clovers, and they almost all of them have more protein content, and the best ones of them are double of the other crops. There's some sugar beet there, which was the most productive in terms of dry matter per hectare, but with a very low protein content. So the answer to the question is that we should biorefine the grasses, because if we can extract that protein, substitute some of our soya import from the other side of the globe, there's an interesting business case for Danish farmers. It would hopefully be much more sustainable. We are working on the LCAs and that. We could produce over the years much other products in that biorefinery. We think it's better to start with the main flows, the mass flows, which will be in food and feed and energy. And then over the years we can extract some of these high value but small amount components also. We are working on that already, and there are many interesting aspects. So we developed a pilot facility that could take approximately 1 ton of fresh grass an hour, and it created a lot of interest with farmers, with politicians, also NGOs, all actually would like to see this system change if it ends up becoming a good business case. We press the grass in a screw press, get a grass juice, which is where the protein is precipitated with heat in the tank to the right. And then we get a protein product that is comparable in quality to soya. And we have made, it's almost as good as soya at the moment. We're still working on the last details, but we have had feeding experiments with pigs with exactly the same quality of meat and feed efficiency as from soya. Chicken and broilers as well, and feeding then the fiber fraction we get to cows showed us a 10% increase in milk yield, because we pre-chewed the grass and took away the easily available protein, which is no good for a cow anyway. So then the interesting thing is whether a business case is possible on this, and it's still under development because the technology is under development, so take care about the results. But some of the background data is shown here, and have a look at the differences between organic and conventional agriculture. There's a almost similar price on the grass product, but there's a double price of organic soya compared to conventional soya. And we have quite a big organic sector in Denmark, and they are at a burning platform to achieve certified organic soya, buying it today mostly in China, and buying a local product would be much better for them, and it's actually difficult to achieve the products at all. And it actually shows on paper today that it's a good business case to make this biorefining of grass on organic products. It's not a good business case on conventional farms, but we didn't price the many environmental benefits at all in this calculation. So if we would be able to do that, if there would be incentives available for the farmers on these environmental benefits created, it will be, I'm sure, a good business case also on conventional farms. So we have also built now a demonstration plant 10 times bigger in order also for our engineers to get experience on how to upscale the process. And they have had very nice results over the summer, improving many of the technical issues a lot. And from next year, we expect the first commercial plants to be operating, or at least to start digging the soil to establish their plants. So to conclude, I am confident that these green biorefineries can be a tool to disrupt these locked-in systems because we need a better integration with technology and primary agriculture in order to break that old-fashioned system we have with grain crops that are actually a very high-tech product that we then feed only to animals. It's only 2% of the grains that we produce in Denmark that goes for direct human consumption. The rest is used for technical purposes and mainly for feed. So we could reduce that a lot, making it from much more environmental friendly crops and achieve a better radiation use efficiency over the year. Less nutrient losses, less pesticide losses and uses, and soil carbon storage, and finally a better license to produce for the farmers. They are in serious troubles somewhere, and now I remember what I was wanting to say in the beginning. I think they have come into a dead end, many of the farming systems of our efficient productivity. There's no more development potential, and I think this is a route to change that. Thank you.
That was just, again, so interesting. So I know now it's the end, but I think we should enjoy the opportunity for questions for those of you that have for Lee or for Uffe. Yes. Okay, one there, and after Yvonne, so Davide.
Thank you, Laurie. I have two questions, one for Uffe and one for Lee. Uffe, very interesting. Thank you for the presentation. I was wondering, when you compare the prices there on the organic versus conventional, I was thinking, wouldn't you compare it to producing something from that land? I imagine you're replacing barley or some. I mean, you're using the land. The land you're using to make grass was previously used for barley or something like that. That was my understanding. Wouldn't you compare what you get out of, let's say, the two pathways, barley or grass, in terms of cost and
well, yes. Finally, in an LCA, we will do that. This is just a basic business case. And it's not trying to see what we substitute. On a larger macro scale, of course, we will have to see all of these products, how are they produced, but that's, I think, the next step. For the farmer, the local farmer, this will be the base business case.
Yeah, but I was thinking, isn't it the barley subsidized today? So where business case...
I think there's a need and also a potential for manipulating the cap a lot.
Yeah,
because today we are substituting crops, and we are not giving substitutes to have a better environment, and we could do that.
Okay. Yeah, we can discuss later even.
substitute you get for these two different cropping systems at the moment.
Okay. And to Lee, you had one slide from, I think it was from the past, maybe 2012 or something, where the performance of biopet, if I recall well, and was better than the counterpart fossil. But if I remember well, there was an opposite result in Biosprit or in more recent studies. So did you see a change in this trend? It was one of your slides where bioplastics were better, but this is not what I could see in recent results.
Yeah, so in Biosprit, we looked at aggregation of all 16 impact category. And in my earlier work, we only look at the greenhouse gas emissions, like many other scientists. And I confess that's not complete, but for an innovative product, that's probably all you can do at that time with the data you available. So yes, in terms of greenhouse gas emission, without land use change, bio-PET still, they look still better. Even in the Biosprit, even in Biosprit, we include the land use changes. So in Biosprit, the problem of PET is not greenhouse gas emissions, but particulate matter from open air burning. So that's something, if you only look at greenhouse gas emission, you don't capture that.
Yes, I come back to grass. You said you produce 20 ton dry substance per hectare of grass. What is the moisture? Moisture.
The moisture content of the grass at harvest is 80%.
Okay, so when you say you store the grass prior to processing, because you crop the grass not all the year long, I suppose?
It's necessary to process the grass more or less immediately because the quality of the protein degrades quite fastly after harvest. So we need to plan for a continuous harvest over the season from May to October, which then leaves half of the year left. And you may think of other developments there, but still it's better than the sugar beets and the potato starch. They have a shorter harvest period, so it's possible.
As far as production of biomass per hectare is concerned, you say 20 ton dry substance for grass, just is 25 ton for beet.
Yeah, yes.
Okay. Then another question for plastic, bioplastic. You were talking about polyethylene out of renewable ethylene, presumably from ethanol. At what price should be the ethanol to be competitive?
For ethanol, at which
to
oil
produce
price?
ethylene out of ethanol.
At which price? I don't know by heart. No, I did a lot of environmental impact, but not so much on cost.
Okay.
So in Brew, we did look at that, but that's pretty old. You need to run the scenario again to update crude oil price and such, and you know what's influencing what. Yeah. So it's commercialized. It's Braskem, and they are producing it. Of course, they will never tell me their cost construction, but the chemistry is rather simple. It's dehydration. Yeah.
Okay. Thank you for your presentation. It was very nice. And I have a question about the energy which is spent, lost for recycling, everything like that. Are the data easily available, or is it very easy to access to this kind of data for not only PET but many things, or is it difficult
So in the Netherlands, these data are available. So basically, incineration with energy recovery, that's the status quo. A landfill is prohibited. And the energy recovery, so with incineration factory, they publish the full energy balances. If you know the PET and well, higher heating value, lower heating value, you know a bit about the composition, you could do quite a lot. For incineration, no.
It is not an incineration, it's for production or recycling or something like that.
Oh, yeah, well, this is very difficult, very, very difficult. So the agriculture part is already difficult enough, even if there is not really much confidential data around, but you do need to get, think about the Brazilian data, the land use change and stuff. It's not that easy. And the conversion step is also not that easy, so we rely a lot on what has been published, we contact the industry. Some of them will provide some information under the NDA agreement. Some of them will, it's not that easy. And I didn't mention the more difficult part is to have a good benchmark to compare. So the fossil fuel polymer, it's completely a cloud. There's a number, and what is behind that number? It's a plastic Europe cloud, I call that.
Thank you, both of you. It was very interesting. My questions go to Uffe because you forced me to think out of the box, but I'm a concrete person, a pragmatic person, so I need you to help me to understand this project. First, very concrete question. What is this kind of food that you can make out of grass? Is it food additive or is it real food? Or if you want, I can make the full range of questions. Second, I was also puzzled to see that chicken would eat grass. For me, it's again thinking out of the box. How naturally does the chicken go and eat grass? They're not used. And finally, I was thinking, so you convert cropland to grassland and finally produce feeds to eat, for us to eat meat. So are you telling us that all the message we heard still during all day long was to eat less meat, and you found a way for us to eat meat and have a less greenhouse gas emission balance?
Yeah, taking it from behind, I think that's taking it from behind. I think the latter question is up to you. I think it's up to you whether you will eat less meat or not. I think it's...
If you only consider the conversion cropland to grassland, but then if you add this phase that it produces feed for animal and you add the animal production
Of
system...
course, it will improve, but that's, I think, up to you to choose if... Because in the beginning it can substitute all of that soy we import for animal feed. But afterwards, if there's a shift in the population, we could make the proteins that we today also import for vegan products from soya. We could produce that from local sources. It's more complicated because of the novel food regulation. We didn't eat grass before, as the chicken you mentioned. The chickens, of course, yes, and as also pigs, they eat grass if they are free range, but it's quite a small fraction of chicken and pigs that are free range, and the other ones are, these farmers are not going to feed them grass because it's not efficient, so they will feed them soya. And there we can make a product which is easily digestible like the soya because we've taken it away from the fibers that are also in the grass. So it's a matter of efficiency. And also most organic production is becoming more efficient. So they also use soya instead of letting the hens and just eat grass. If we remove the fiber, yes. Yes, I only had a short opportunity for telling the whole story, so I made shortcuts. So there are papers behind.